Welcome to the session. So my name is Rajesh. I'm a principal PA manager in SQL DB team focusing on business continuity in our team and data virtualization. So today we'll talk about perfecting business continuity for SQL DB. And here's the agenda. So we'll talk about business continuity, what it is. I'm sure you're here because you wanted to learn more about it and how do you make it perfect. We'll talk about 3 pillars of business continuity. So those are HA, availability, high availability, and DR. And then I have a couple of demos in HA to keep it really interesting and drive the point across. And then we'll end with takeaways. So takeaways for HADR checklist, and then a takeaway for outage recovery guidance. Right? So if you look at what's business continuity, this is a quick slide just to drive the message across. But we all get the message that end of the day, we want our business to continue in the face of disruption. Right? And the disruption could manifest in many forms. It could be an accidental deletion of data, so someone accidentally deleting the data because they do some oops kind of situation where they do a select star and then delete star and get rid of all the data. So that falls in the human errors. Equipment failures, right? So these errors happen in the cloud world. It's inevitable to happen with so many systems in place. You will land into situations where there are something or the other failing in our fleet, right? Natural disasters, unfortunately, we are also seeing a lot more of these that happen in the recent times. And then man-made disasters, these are something that, again, are inevitable. We are starting to see, we are in this day and age where things do happen, right? And we have to prep for that. 3 pillars of business continuity. First pillar is availability. So as a platform, as a service provider, this is our responsibility. So every database comes with its core resiliency and reliability promise. So think of this as a platform as a service provider's responsibility, right? So this is something that we have to do. We give you right off the bat. It's off-the-shelf feature. And we also do automated backups. So these are things that happen behind the scenes, and you don't have to worry about it. And we also provide you industry-leading SLA guarantee of 4 nines. Now, the reason why I highlighted it in bold is this is a SLA based on credits, meaning if you breach the SLA, you can call into the support, tell them, hey, my SLA has been breached, and then request credits. But this is based on what you spend on the Azure SQL DB, right? It doesn't give you protection against the amount of business that you lost. So this is an SLA against a number, and then if we breach, you can say we give you 10%, 25%, or a 50% credit, depending on the SLA that we breached. The key point that we are trying to send across is make sure that when you call in, when you have expectations on availability, this is based on the number that you would see in your monthly bill, right? Now, the only way to improve the availability is by enabling high availability. And this is the second pillar. And the reason why it's a second pillar is it's an opt-in feature, wherein as a customer, you turn on zone redundancy, which pretty much translates into high availability, right? Across the board, what we have seen is with all public clouds converging into this nomenclature where high availability translates to zone redundancy, right? Gone are the days where in the on-prem world, where we had 2 redundant servers next to each other, and we called it as high availability, right? In the public cloud, for you to make sure that your application is shielded, the only way to ensure that is you have 2 deployments in 2 different zones, right? Every region has 3 zones. As you can see in this picture, pretty much most of the Azure regions have zones, and a zone is comprised of 1 or more data centers, right? The moment you make a SQL DB zone resilient, you will ensure that the DB is spread across, storage is spread across, compute. We'll talk about the various options. The DB becomes resilient to failures across availability zones. Key advantages with zone redundancy is recovery is automatic. As you will also see in a couple of demos, you don't have to do anything. It automatically recovers when there is a failure. So if there are failures that expands an entire data center or a zone, your recovery is automatic. It's quick, because when something goes wrong, we'll ensure that if your DB is resilient, you have the spare capacity in additional zones or the necessary compute in the additional zone for the DB to just come online, right? And it's also transparent. So an application doesn't have to do any changes from an application point of view. Enables zone redundancy on a DB, it just works right off the bat. And it also gives you a higher SLA. So from the 4 nines that we saw in the previous pillar, we go 0.5 higher with 99.995 for high availability, right? And the third pillar is DR. Again, this is a customer configured option wherein you establish redundancy across zone, resiliency across regions, right? High availability is within the region where you enable it and then you take advantage of the availability zones. But disaster recovery is when you want resiliency across regions, from primary region to a secondary region. Again, this is customer configured, wherein you have to go and turn on a knob in order to leverage that. And for SQL DB, we have a couple of options, failover groups and geo-replication. And then we'll talk also about geo-restore, which is one of those hidden gem that's available in SQL DB. Right. One key factor is, as you go from left to right, your price goes up. It's understandable, because you are adding more layers of protection. From availability, you add on HA, there's one price point there. And then when you add DR, your price point goes up. One thing that I want to call out is there is no additional price, though, for business critical and premium service tiers when you enable HA. That price is already included. So if you are using business critical or premium, it's a no-brainer to just turn it on, right? Test your application, test the end-to-end, run the workload, and just enable HA. So this is something that you should just leverage today. Right. One thing that you also get as you go from left to right, because you're paying higher price, you get a higher business continuity protection, because now you're adding multiple layers of resiliency to your whole database. Right. Let's see this in action, right? For this example, let's take a hyperscale database as an example. And a dot here represents the primary compute. So in the hyperscale architecture, in a database, you connect to the primary compute, and a dot here represents the primary compute, right? In availability, we place the primary compute in one of the data center, one of the physical node on which the DB gets hosted. There are other moving parts, like page servers and the log service, which we are not replicating here. But for the sake of simplicity, imagine this as one dot, which is a database, right? Now, the moment you enable HA for hyperscale, you get a HA replica, which is enforced by the system. So we will make sure that your compute is in zone 1, and then your HA replica is in zone 2. So that's the placement promise that we adhere to, and then we guarantee that the DB is resilient to multiple zones. Right? And then for DR, you replicate the whole process. So you have the primary region where you have compute, HA replica, and then you have a similar topology for your DR side of things as well. All right. Any questions on the HA, and then we'll talk about any questions on this part? OK, it's a smaller audience. OK, all right. Yeah, so for any discussion on business continuity will not end if you don't talk about RPO and RTO. So if you look at RPO, it's the data loss that you incur when a disruption happens, and RTO is the downtime that you incur when a disruption happens. Now, across the 3 pillars that we are talking about, if you just look at what's the data loss or the RPO that we're looking at. So if you look at RPO as a data loss, for availability and high availability, as I said, this is a promise that as a service provider, we guarantee there is no data loss. There are some outliers, but this is definitely an outlier. But for the majority or for most of the cases, the data loss is 0 because of the redundant nature of our systems, and then there are multiple copies of data, so you pretty much are guaranteed that you will not lose any data. Now, when it comes to DR, the 3rd column, and the 4th column, which is again for geo-restore, because data is synchronized in an asynchronous fashion, so we replicate asynchronously between your primary and secondary, there is potential data loss. And the reason we call it as potential is, depending on when the disruption happens and the changes that haven't been synchronized from your primary to your secondary, you lose those data when you do a forced failover, and you promote your secondary to primary. Right? In terms of downtime for RTO, in availability and high availability, again, this is a responsibility as a service provider, as a platform as a service provider. It's on us. And we make sure that it's typically less than 30 seconds. So let's say if a compute goes down, another compute pops up in less than 30 seconds, right? And this happens both in availability or high availability fashion. So across zones, we ensure that you have the spare compute, and then you have the spare nodes, which are ready to take on the workload as and when things go wrong on your primary side. Now for DR, it gets interesting because when primary is down, and then when you're trying to initiate a forced failover, you definitely are looking at a potential data loss, which is something that is workload dependent. But we ensure as a service provider that when you hit that forced failover button, we want to make sure that your secondary does come online, gets promoted to primary, and typically we are looking for less than a minute or so for your secondary to take on the load. And then if you're looking at geo restore, which is restoring from backups, you're looking at a higher RTO. And this is because of the size of data operation, right? Because you're trying to restore from a backup, and restoring from a backup is a size of data operation. It does take time depending on the backup. Any questions on the RPO and RTO? Okay, all right. All right. Quickly moving on to the resiliency scope. So this is something that we want to make sure that you understand, as in how are we handling all the three pillars across the various buckets of faults, if you may, that we encounter in our fleet. So what pretty much we have seen is we do a lot of infra failures that can happen within the data center, and these infra failures are bucketized up and down the stack. Name it from a networking component, a top of rack switch, or from a compute or a storage compute cluster, right? All of those fall in the infra failures. And then a bunch of VM and software failures. As we deploy software, as we start releasing updates, we could introduce some regression. So those could also cause some faults, right? We also do a lot of proactive maintenance for us to make sure that we are in compliant with a lot of security standards. We need to ensure we roll out these updates. These come in once in a month or even once in a week at times, where we have to patch the entire fleet to make sure the fleet is all fresh, right? There are, at times, you also see availability zone or data center failures, right? These also happen either because of service outages, where we deploy some updates, it take down a particular set of compute clusters or a particular data center, or from natural disaster, right? And we have seen this happen in the recent past, where you could have some weather-related events and one of the data center getting impacted. Or a region failure. In reality, region failures are very rare. You don't see an entire region going down. But what we have seen is manifest a region failure is when we take dependencies, and we do take dependencies on some horizontal services, let's say Azure networking, or an Azure Active Directory, which is the Microsoft Entra ID, or the Azure Resource Manager, right? These are all, again, horizontal services across the region. If those go down, then the downstream services get impacted. And SQL DB is one of those downstream services. Now, if you look at the protection that you get for availability, you pretty much are guaranteed for the first three layers. We protect you against infra failures, software or VM failures, service maintenance. What it doesn't guarantee is availability zone failures, right? Because that's something localized to a particular data center, so you will not get those protection in the availability. And obviously for region failure. Now, the only way for you to get that additional protection, which is a no-brainer in the public world, is enable the zone redundancy option, right? In that case, you get protection across everything except the regional redundancy. And then to have the maximum protection for both local and within the region and across regions, you enable DR as well. So that way, you are protected against the whole gamut of failures. All right. With that, let's quickly jump on into some architectures for high availability. And this is not new. I mean, these are some things that have been there for a quite long time. I just want to make sure that it's a refresher for you to understand what these architectures are. And then we'll jump into a couple of demos where it drives the point across. Right? Now, if you look at high availability for business critical and premium, as you all know, business critical and premium, we run always on availability groups for you. Right? End of the day, you're just passing on that management and the maintenance overhead for us, and then we run it behind the scenes. So for us, it was very simple, wherein instead of having these 4 replicas behind the scenes for always on availability group, we place it across multiple availability zones. So here you have a case where you have 2 replicas in zone 1, the third one in availability zone 2, and the 4th one in availability zone 3. And what it does is, it does synchronous replication across the 4 replicas, nothing new, the traditional always-on replication that you do on-prem, right? The key point, again, as we just talked about in previous sections, there's no additional price for BC and Premium. So it's a no-brainer that you just enable it right off the bat. Now, let's look at general purpose. Now, for general purpose, think of this as you have your compute, and then the remote storage is on Azure Storage. And what we do for remote storage is we switch from the local redundant storage to a zone redundant storage. So as you can see in the bottom layer, the storage is redundant across all the availability zones. You have your primary compute. Let's say in this case, the first one is an AZ1. But we also have additional nodes in the other availability zones, which are again reserved when you turn on zone redundancy. And if something goes wrong to the compute in zone 1, one of the compute in zone 2 or zone 3 gets promoted, the files get attached, and then you're back in business. There is an additional charge for general purpose because we reserve capacity for you in additional zones. In the event a failure happens, so that's why you see that additional price. This roughly translates to about 30% uplift from your regular non-zone redundant database. So that's one key point to remember in terms of price. Now, for hyperscale, it gets interesting because there are more moving parts here. But I'll break it down. If you look at, if you have caught up on the other sessions that we did in SQL Bits, for hyperscale, we have 4 layers. So you have the compute layer, you have these log service, then you have the page service, and then down at the bottom, you have the redundant Azure storage. Now, if you talk about the compute layer, we create a HA replica, and then you have your primary compute, which is where you connect to. But the moment you turn on zone redundancy, we create a HA replica, and we make sure that the HA replica is in a different zone than the primary. So that way, we avoid the single point of failure for the compute layer. Now, what we do for the log service, it's a microservice. Behind the scenes, we have our own implementation of how we run the log service. So today, when it runs, we make sure that we replicate across the zones. So we've spread the compute across multiple zones for the log service. This is something that you don't have to worry about. It's our responsibility. But we'll make sure that the log service is resilient to zone failures. Now, for page servers, as you might have seen in the other sessions, every page server has a primary and a secondary pair because we want to avoid the single point of failure. And each page server holds a chunk of data to support from. In this case, it's about 128 gigabytes of your data. And as you can see, it may not be obvious because of this projection here, but you will see each page server with the color coding here will be in one of the zone. The primary is in one zone. The secondary is in other zone. As you can see in this, the page server one copy is in, the compute is in zone 1, and then the other secondary is in zone 2, and so on and so forth for all the page servers. Now, down at the bottom for the Azure storage, we use a zone redundant storage. So instead of local redundant storage, the 3 copies of Azure storage, they get spread across 3 different zones. So that way, we avoid a single point of failure across the stack. Bottom line, there are more moving parts for hyperscale, but you don't have to worry about it. When you enable it, we make sure that we spread across the availability zones, and then we take those, we leverage those zones to avoid single point of failure. One thing that I want to call out is, for hyperscale, when you enable zone redundancy, you have to do it when you create the DB. Once you create the DB, turning that flip on is kind of involved process. So you'll have to use one of those options until we'll give you an option where you can change it in place. So that's something that we're working on. We'll soon try to get it out. But until then, you have options where you have different routes to take when you want to turn it on after the fact, right? All right. Any questions before we get into a couple of demos? I know it's a shorter audience, but do you have any questions before we get into demos? OK. OK. So this demo should get it interesting. So one demo, let me start with this one. Let me start playing this. So this is in a simple application. What it does is I'm leveraging an Azure SQL DB sample. And this is by one of our colleagues. He's a known MVP. And what he published is this connection resiliency things that we can take advantage of. And it's a simple console app. When it runs, I'll show you how it looks like. It has 3 threads. The first thread, it does a bunch of insert. It follows the best practice. opens the connection, inserts, and comes back. Thread 2 simulates an ideal connection, opens a connection, doesn't do anything for a couple of seconds, then does an insert. Thread 3 simulates a scenario where something is running for a longer duration of time. So it runs a query, waits for 2 seconds, and then commits. So that simulates long-running connections, right? Now, if you look at the hyperscale database here, I hope this is visible. Yep. So we have a hyperscale DB. It's a 2V core Gen 5 DB, and I've created it in East US location, and I've enabled zone redundancy. Now, to confirm that, if you go into the properties section, you will see these two options, wherein the HA replicas is enabled, the zone redundancy is enabled, and that gives you one HA replica, as we talked about in the previous slide. And then let's get into a command. So I'll show you one command. So let's get into the app. We run the app. It's a simple console app, doesn't have any fancy UI. But we'll start the application, and once it starts, it connects to your primary compute, and then starts running the workload. The workload is simple. All the 3 threads run an insert statements. These run depending on the type of the thread. The first thread starts inserting continuously. The second does an idle scenario, and the third one does a long-running scenario. End of the day, all it does is connects to the DB and starts running inserts. Right? Now, while this is going on, the app is connected, everything is running. So let me show you how it looks like. Let's visualize the data, right? So I've created a simple Power BI app, connects to the database, and then gives you a count of the queries, right? So the number of records currently in the table is about 25, right? That's a simple, we've just started the workload, so it's about 25 records in the table. Now, in the lower half, what I'm trying to do is I've used a lag function to see what's the time difference when the previous insert happened. So I'm comparing what time the insert happened, and then every time a row is inserted, what's the time difference between them. So you'll see roughly about 2 seconds is when the workload kicks in. Now, we expose this option called Azure SQL Database Failover command. So this is one of those commands, I hope this is visible, where it gives you an option to simulate a fault, right? What it does is it kills the primary compute, almost gives you an option to simulate, let's say, if something is going wrong in a data center, how does my application behave? So this is one of those commands where you can simulate faults and then try figuring out how does your retry logic work, or how does your application react to these kind of faults. You pass in the server name, database name, and this is all in real time. It takes a couple of seconds for it to complete. And what it's doing behind the scenes is, as you saw in the previous diagram, you have your compute and then HA replica. The HA replica gets promoted to a primary, right? And then you'll get one more HA replica. Now, if I go back into the Power BI and then start refreshing, you will see how the application behaved when this was happening under the hood. So the number of records went up from 25 to 129. But more interestingly, you will see that there was a 14-second that it took for the failover to complete. So imagine this in a real-world case, wherein something went wrong on your primary data center. You take a 14-second downtime, and then your HA replica gets promoted to your primary, and everything goes, everything is back up and running. Now, in the console app, this was a well-behaved console app because it was built on a sample, so all the goodness was baked in. So you will see entries of retry, exponential retries, all that goodness in this. It also has connection pooling, so it doesn't create a lot of connections, gets the data connections from the connection pool, and then retries, because now that the primary compute is broken, it will keep retrying, and once it gets connected, it will start coming back online. So that's a quick demo about how high availability works. As you can see, once you turn that option on, the key message is the recovery is automatic. You don't have to worry about it. And it's transparent to the application, because once you have the retry in the application, everything just goes on by itself. Right? Now, this is another demo. So before we get onto this demo, I want to quickly talk about what it does. So this one simulates a real-world e-commerce application. So this is one of those internal applications that we within Microsoft use. There's a dedicated team where we have these workloads developed by them. And they run these workloads in a zone failure scenarios, right? I mean, we do a bunch of zone down drills to test how things work. So it's an application that was built for that purpose, and I've repurposed this for this demo. It simulates a real-world e-commerce application, wherein customers come in, they browse the application based on APIs, and then they add a bunch of items to the cart, and then when they're done, they check out, right? So let me start playing this demo, and I'll explain the app as it goes. So this gets real interesting compared to the previous one, which was pretty lightweight. So you have an application, it's an API, and then it's talking to the application gateway where the SSL termination happens. Then it goes into the ILB, which is an internal load balancer. Connections go to the load balancer. And then eventually, it goes to Kubernetes services. So we have a bunch of pods wherein it's a microservice application, and each microservice application, there's dedicated microservice application for various parts of the application. Like you have the cart application, it goes into a Redis cache as people add items to the cart. And then when they're ready, when they start checking out, it goes to talks to the checkout microservice, a typical cloud-born application architecture that it follows. And then for durability, it goes to Azure SQL database, which is where we'll induce a fault. And this currently uses a SQL hyperscale DB, right? And it uses our Entra ID for authentication. Nothing new, pretty much what you would see in a standard cloud pattern application. This gets really interesting because here we are inducing the workload. So the workload that we're inducing generates about 28,000 requests per minute. So very close to what a real-world e-commerce application looks like. Roughly about 28,000 requests per second, right? And the JMeter also does a bunch of other things. So we measure the API latencies and a bunch of other things. So what we do here is we measure the application health. So it's based on all APIs. So we have a section for the e-commerce web API where it measures the API health for various APIs, like adding to the cart, browsing in the cart, and then checking out, and then saving it to the DB as well. We also measure the health for Kubernetes. And as you can see here, everything is hunky-dory, everything is healthy. This is for the Redis cache part. That also looks healthy. Looking at the gateway, that also looks healthy. And then down at the bottom, we have the SQL DB, which is a hyperscale DB, and everything looks healthy. So this is a Grafana dashboard built on to measure how the end-to-end health for the application. Now, again, let's going back to the database. This is a hyperscale DB, just like what we used in the previous demo. It's a 2-week core HSDB. And then we'll quickly see the properties to make sure that confirm that this is indeed zone redundant. As you can see here, the zone redundancy is enabled, and then there is one HA replica, which we talked about in the architecture slide. Right. Okay, so once this is done, I'll show you how does the application look, how does the DB looks like in terms of the workload. It is generating workload, so 28,000 requests per minute, and it's roughly at about 20% CPU. Not too busy, but still busy enough for us to see what's going on here, right? And then you also see the workers count, which is about 20% of workers that have been used. So it definitely is busy, not an ideal application that we saw in the previous cases. Play this. Yeah, sorry about that, I had my clicker. So as you can see here, that's about the CPU, and then I was showing you about the workers percentage, which is about 20%. Now, once this is all going, what we'll do is we'll induce the same thing that we did in the previous demo. So we'll go into the command line and then invoke the same command. And it's doing the same thing. It induces a fault. Imagine this as a fault that's been induced on the data center or an availability zone level. It comes in pretty handy, as I was explaining. And then we pass in the resource group name, the server name, and the DB name. So once this is done, we'll see how the application behaved. In this case, the workload was running. Imagine a bunch of people are browsing through the application. They're adding items into the cart. And our goal for this is to make sure that we don't lose any of the cart or any of the checkout process, right? We want to make sure that the end users have a seamless e-commerce browsing application. Now, once this is done, we induce a failure, and then you can see the entries in the activity log. So when we induce those failure, you can go into the SQL DB activity log and then see the entries for these failures. So we started at about 8 seconds, and then once it finishes, it's about, 34:23. So roughly it took about 15 seconds, in line with what we saw even in the other demo, right? Takes about 10 to 20 seconds for the whole failover to complete. for the HA replica to be promoted as primary. Right? And then now let's go back into the Grafana dashboards. Here's where you will see all the blips that we introduced, and then how did the application react to this. Now, if you get into the Grafana dashboards, you will pretty much see that blip that we saw, right? From 28,000 requests, it fell in almost to, 22,000 requests per minute. And the reason why you see that still a high number is because of the retries that the application was doing. It was able to pick up, but you will see that blip that happened for the application, right? And then let's check into all the errors that we see. Now, for the API health, it definitely got some errors because it was trying to connect, and then it couldn't, so you will see some server errors behind the scenes. Now, down at the bottom for the database too, there was some failure, right? When we induced this fault, this was definitely a failure on the DB side. So connections got disconnected, and then retries kicked in, and during this whole process, there was some amount of server error. But you'll definitely see that point wherein you saw the blip. And same thing on the metrics. Now, if you go back into the portal and see the metrics, you see the CPU dropping down. The granularity is 1 minute, so that's why it's really quick when you see that 15 seconds in a minute. But then as we aggregate, things look really stable. So you see the blip, and then the workload picks up, and everything is back in normal. Right? All right. So that's the 2 demos. So any questions here before I get on into the next sections? OK. All right. All right. So that's the key message that we want to send across is the moment you enable zone redundancy or have HA for your application, you're pretty much set. I mean, you don't have to worry about anything else. If you have a well-behaved application wherein you take care of the retries and the connection pool logic, everything just happens under the hood automatically for you. Switching gears, let's move into the next topic, which is for disaster recovery. Now, as we saw, the first 2 pillars, availability and high availability, the third pillar is this is redundancy across regions, right? And this is an option that you turn on because you want resiliency from 2 regions, right? You have your primary region. Now you want your redundancy across the other region. We see a lot of customers do it for DR, but we also see customers who want to enable it to scale reads. So let's say they want to enable a scenario where they want to scale the reads, not from your primary region, but from a region that's closer to your end user's application or the location of the end users. They also enable DR on this scenarios. We also see use cases where someone wants to relocate their primary. They set up DR, they go from A to B, they add C, and then they fail over to C, so that way they can take away A from the topology. So that's also one other use case that we have seen come up in this case. 2 options to enable DR. One is geo-replication. The other one is failover groups. Geo-replication works at an individual database level. So what we do is you go into the portal, pick a particular database, enable DR for that database, and then we asynchronously replicate your changes. DR is always asynchronous because we are talking about changes being replicated across regions, right? Now, on the right-hand side, what you have is failover groups. And what failover groups will do is, as the name suggests, it gives you an option to group a bunch of databases. So if you have any application where the DBs are interdependent and you want all of them to fail over together, you put it in a group, and then you fail them over together. What failover group also gives you is this neat connection endpoints, which don't change no matter what the primary is, right? Who the primary is. You do any failovers, the read-write and the read-only endpoints don't change. They always remain constant. So you don't have to make any changes in the application connection strings. Quickly talking about failover policy in failover groups. So this is something that we have recently made changes to the failover policy. In the past, what happened was there were 2 options that we exposed for the failover policy, automatic and manual. And we always defaulted to automatic, which is what we set for the default option. And then we used the auto failover groups as a branding for the failover groups. So what we did recently is we pivoted away from those options, and then we renamed those options as customer managed and Microsoft managed. This is more intuitive, wherein it puts a responsibility as a customer to let you know when you want to failover. What it essentially does is we call the manual failover policy option as customer managed, and this is the recommended one, right? And what we recommend customers is, when you set up DR, you are in a better control to decide when to failover. So you pretty much want to go with customer managed as your failover policy. Now, Microsoft Managed, as the name suggests, it translates to automatic failover policy. But as you can imagine, for Microsoft to initiate failover of all the failover groups in the region, we definitely take some time, right? We definitely want to make sure we have done our due diligence. We assess that this is indeed a failover. This is indeed a disruption event wherein we have to come in and do the failover. And when we do the failover, we failover all the failover groups. So we are not granular. It's all or nothing for the entire region. And that's why you'll feel this as, hey, why are you failing over when I didn't expect you to fail over, right? In those cases, as we recommend, go with customer managed, which is your best bet. And if you look into the portal, if you want to make these changes, we also made sure that the failover policy gets updated in the portal. So these are all recent changes that we have made based on our learnings that we have from outages. So if you want to change, you can go to the edit configuration and then pick customer managed, set it to customer managed for the failover policy. And this we have seen a lot of feedback from customers coming in, because when we initially introduced and we defaulted everybody to Microsoft Managed, they were taking unnecessary failovers when they didn't expect, right? They wanted better control, and this is how you get control of your DR options. Quickly talking about standby replica. So this is something that we recently introduced at Ignite as a public preview. We have been getting a lot of feedback from customers saying, we set up DR, but we don't really use it. We only use it in the event of a disaster recovery, and that doesn't happen often. It's a good problem to have. But then customers said, hey, we create a full-blown DR, and then we have to pay 100% more than our primary. It doubles our cost. What are the options that are available? So what we did is, when you set up a standby replica and you just use it for a DR purpose, we completely waive off the license. So this gives you 40% discount. So now you're better off to enable DR at a lower cost point when you don't use DR for any reading purposes, right? So you just set it up. It's always available there. In the event when a disaster strikes, you fail over, but you get that 40% discount, and then you can enable it for general purpose and business critical. You don't have this for hyperscale because, as you might have heard in this conference, we recently took off the IP pricing, the license pricing for hyperscale across the board. So you don't have it for hyperscale. But if you have general purpose, which is a very popular entry point for a lot of databases in our fleet, this is a neat offer to enable DR for those large number of databases. Anybody using standby replica, or were you aware that this was an option that's there? OK, so that's good. So make sure that you enable this and leverage the savings that you can get off the bat. Geo-restore. So this is one of those options that it's a hidden gem in SQL DB, because every time you create a SQL database, by default, we pick this geo-redundant storage as the option for your backups. And what it essentially means is we store 3 copies within the primary region, but we also automatically copy them to your paired region. So they're always going to your paired region. You don't get to choose what's your paired region. Let's say you have your primary in West Europe. If the paired region is North Europe, we automatically replicate the backup copies to your paired region. They're always sitting there. Now, what you can do with this is, if you haven't enabled any of the DR option, as in failover groups or geo-replication, for various reasons, because it's cost prohibitive, you don't need DR, or you think, hey, our application doesn't need a standby replica, it's still expensive. As long as you have your backup set to GRS, you have these backups in your paired region always waiting for you, right? And what you can do is, when an outage strikes your primary region, you can go to any server in any of the Azure region, pick those geo-redundant backups, and then restore the database from those backups. So think of this as your last resort for DR, if in the rare case where your primary region is down for an extended period of time, right? And the way to look it up in the portal is, on the create database, you have this option to go to additional settings, and then you pick a backup in the drop-down list, and then you select the backup that you want to restore from. The only disadvantage with Geo Restore is the RPO is higher because we replicate backups at a 60-minute interval. I mean, the Azure storage does replication, but we have seen times where it takes roughly about 1 hour. Let's say if a full backup has happened now, it takes 1 hour for the data to be replicated, right? Because it's across regions and used by Azure storage. So if you're okay with that kind of an RPO, this is one of those options that you can still use. And we also have PowerShell and CLI. You don't have to use it from Portal. You have all the command line options as well to leverage. Now, okay. We are almost at the end of this deck presentation. Takeaways, right? We get overwhelmed when we hear too many things. I just want to break it down. What are the key takeaways, right? One of the checklists is for availability, make sure that you have retry logics and connection pooling. It's inevitable that in the cloud world, when you're dealing with any kind of deployments in the cloud, you will always have transient failures. And these transient failures happen up and down the stack. It could happen in the connectivity layer, it could happen in the backend, or it could happen in the control plane layer. And you're shielded from all of these failures as long as you have the retry logic, right? And we saw that in a demo where as long as you take care of this in your application, the recovery is very transparent. You don't have to do anything. Now, for high availability, for you to shield yourselves from data center level failures and make sure that you have high availability, enable zone redundancy, right? So this is one of those things where in the cloud world, gone are those days where you cannot rely on just one data center. As the amount of changes get deployed to the cloud, and this is a matter of fact for any public cloud, right? For you to run any production application, if it's backing any critical application, enable HA and then have the zone redundancy in place. For DR, use failover groups because that gives you a neat abstraction wherein you don't have to change your application connection string. Everything remains constant. You just have to use those connection endpoints, use failover groups, and then set the failover policy to customer managed, right? So that gives you an option wherein puts totally you in control, and then you decide when is the right time to failover, and then you don't want to pass on that control to Microsoft managed, wherein we can take you down at any point in time or induce failures when you didn't expect the failures to happen, right? Any questions here in terms of checklist or anything that you want to bring up? Okay, so the question was, does the region ever went down, and is Geo Restore ever necessary? If you have looked up Azure status history, I'll be honest in terms of what, I mean, all of this is public information. You will see 1 or 2 occurrences in the recent past where because of our dependency on some horizontal service, in this case it was an Azure Resource Manager, which is the ARM resource, we had outages in ARM resource, so pretty much it took down the entire region. All the services were healthy under the hood, but then it doesn't matter when you can't get to your dependent service because the entry point had an outage, right? ARM is the entry point when you try to connect or when you do any CRUD operations. So that manifests for an application as a region down scenario. It's not that the region is down as in the data center or the compute clusters or the storage clusters are physically down. They're still functioning. It's just that you cannot get to them because the horizontal service that SQL DB is dependent on has an outage. That's how it manifests as a region down scenario. Yep. So the question is how long the region goes down. Normally, we expect a region to recover in 1 hour or less than 1 hour. So it depends, right? I mean, we cannot, as we have seen with our experience in running databases in public cloud or the public cloud, in general, every outage has a unique signature. When we run any service, we want to make sure that it is resilient. I mean, every service that goes down comes back really quick. But there are situations where some things are outside our control. Like in the specific case of an ARM outage, it was down for about few hours, a couple of hours, and it was intermittent too, wherein a couple of people had, like the failure was not consistent for every customer. Some customers where they were able to connect, they were able to get in, but for others, it was a consistent failure. So in those scenarios, as an end user of an application, you might see an impact which is higher than what you would normally be able to tolerate, right? Let's say your tolerance levels for application or your end SLA is 15 minutes. I'm picking an aggressive number, or let's say conservative number of even 1 hour. And after 1 hour, you start panicking, right? Because you are saying, hey, what should I do? This outage is manifested, it's intermittent. What should I do at this point in time? So that's the time when you start making your decisions, and then either if you have a DR, you quickly fail over, you don't have to wait for the entire 1 hour. But if you don't have DR, because of the high cost that you have to pay for DR, start with at least geo restore. At least get your application back and running, start getting that contingency in place. All right. We also published outage recovery guidance. I'll let you take a picture of this one. This is, again, based off of a lot of feedback that came in from customers, as in, hey, what should I do when a DR happens, right? Exactly the question that you asked. And then we gave you a prescriptive guidance on what should you do. And one of the guidance is, hey, you have an option to wait if your application tolerates, or take any of the corrective actions. And we give you prescriptive guidance on what should you do when you take the recovery actions. And we also guide you to say, hey, start with a failover with no data loss, see if that works. If not, start with a failover that where it does induce some amount of potential data loss, right? So so that's a link that will give you those prescriptive guidance. All right. If you are not aware of freebies, we all love freebies. If you didn't know, SQL database, we supported a free version. Everybody can get a free SQL DB in their subscription. So very neat way for any new customers to start with, developers, or any teams in a business application, in your business teams who haven't used SQL DB, still exploring, but they say, hey, it's a huge cost. Why do you want to spend a couple of $100 just to try? This is a neat way to try. So you get 1 DB free for the entire lifetime of the subscription. All right. I also linked the related sessions. So this covers the whole gamut of SQL DB sessions that we covered from our team here. The first one is about hyperscale. The second one is cost optimization. We also included the data portability. That was a session that happened right before. So please go ahead and watch those sessions as well. Feedback. I know this is SQL Bits is donating for every feedback. So please submit your feedback, so that way we'll be able to donate and have this opportunity to have SQL Bits donate to a charity. Okay, thank you.